Number 21 is actually a really interesting problem because there's two totally different ways of doing this, but I would imagine most of us want to see the way to do it using L'Hopital's rule, which is what we're doing here in 4.5. So the first thing to consider, does plug and chug work? Now, if I let x approach a negative infinity, that negative infinity is going to get squared, which is going to be positive infinity. Oh boy, times 7, all that, that's the only term that matters. We end up with an infinity up on top. Down on the bottom, the 9 isn't really important. We would take negative infinity and square it, okay, and end up with an infinity value there times negative 3. That would get us something like negative infinity. As we said earlier, the negative doesn't really matter. Infinity over infinity is one of the indeterminate forms, and so we can use L'Hopital's rule. So this limit is equal to, again, the limit as x approaches negative infinity of, let's just take the derivative of the top and the derivative of the bottom. Derivative of the numerator is going to be a 14x plus 4, and on the bottom, looks like we're going to end up with a negative 6x. So what happens when we let x become, or I really should say approach negative infinity here? 14 times negative infinity is negative infinity, or at least is approaching negative infinity. Negative 6 times negative infinity, we're approaching positive infinity. We got another indeterminate form, but I think we're making progress. So we're going to go ahead and try to do L'Hopital's rule now for a second time. What I want you guys to notice is that from here to here, the degrees of both the numerator and the denominator got smaller. I think this is eventually going to get us where we need to be. So the derivative of the top is just going to be a 14. The derivative of the bottom is just a negative 6. And now I see there are no x's left here, so the value of x is irrelevant. And our answer is 14 over negative 6, which of course we would simplify to make a negative 7/3, and that is the answer that we come up with using L'Hopital's rule. Now, if I can take you all the way back to the original problem right up here in black, what I'm hoping you guys remember is that a limit as x approaches negative or positive infinity is really just asking you for a horizontal asymptote. And how do you find the horizontal asymptote of a rational function? Well, you look at the degree of its numerator, which is 2, and the degree of its denominator, which is 2 as well. And when those degrees are the same, your horizontal asymptote is the line y equals, and then it is just the quotient of the leading coefficients of both the numerator and the denominator. That's a 7 on top and a negative 3 on bottom. I'm looking right here at the 7 and right here at the negative 3, and that's the exact same answer that we came up with right here. So neither one of those ways is better than the other, although honestly, if you remember your rules for horizontal asymptotes and you remember that a limit as x approaches plus or minus infinity is asking you for a horizontal asymptote, it was definitely easier to do it that way. Kind of like an algebra 2 problem at that point. But if you forgot that, L'Hopital's rule will work out for you as well.